16.5, solving inequalities using multiplication and division. Now, you'll remember yesterday I said, you solve inequalities the exact same way that you solve equations, just like you've always been doing, but there's one exception. Today we're going to talk about the exception. Okay? The exception is this. Whenever you have to multiply or divide both sides by a negative, it flips the inequality. If it was pointing to the left, it's now pointing to the right. If it was pointing to the right, it's now pointing to the left. Okay? When you multiply or divide by a negative on both sides, the effect that it has is it flips the inequality around. That's the only exception. Yeah, Grace.
So what you're saying is if you're dividing by -3, so you flip that other side to where the mouth is opening to the 3?
It's going to point in the other direction, but let's get to a problem because
okay.
you didn't say that just right. Okay, so hang on for a moment. I'm just going to read through this while you guys are getting ready here. It says, multiplying each side of an inequality by a positive number produces an equivalent inequality. That means it's the same. It looks different, but it's equivalent to the thing that we started with. Okay? Now the next one says, multiplying each side of an inequality by a negative number and reversing the direction of the inequality makes it an equivalent inequality. What does that mean? Because it's a lot of irrelevant, inequality. Okay, let's see what it means. All right? Here we go. Example number 1 says, solve the inequality, graph your solution. So we've got 2 things to do. John D., what does it mean to solve? Get the variable by itself. Izzy, is the variable by itself? No. Allison, what's with the variable?
The divided by -3.
Okay, so it's being divided by -3. Lily, how do I undo that? Okay, on both sides though, right? So I need to multiply this side by -3, and I need to multiply this side by -3. Okay. Cedar, what do I get on the left? M. Catherine, what do I get on the right? -9. And Bennett, what do I get in the middle? Less than or greater than?
Less than.
Less than. You see how it's flipped directions now?
Isn't that a positive 3?
Why? Because what was the number that I multiplied both sides by?
Negative.
Caroline? What was the number that I multiplied both sides by?
-3.
Okay. Is it negative? Yes. So I had to flip the inequality. Okay? Because I did that on both sides. So now I've got M is less than -9. Okay? All right? Good. And look, I need the other side to be positive, don't I? So I know that it's got to be negative up there. Because I need a negative over a negative to turn it into a
So
positive.
then would you graph that, or?
Now, it does say graph it.
Wait, why
Okay?
did you put this in negative?
Because you multiply both sides by a negative number.
That's why we flipped it?
That's why you flipped it.
Wait, so you only flip it if it's a negative?
You only flip it if you multiply or divide by a negative number. A positive, everything stays the same.
Okay.
But a negative says flip everything, right? Negative means flip it, the opposite of it. Okay? Cedar, stay with us. Okay? What goes right? How do we graph this thing? Casey? I put -9 in the middle. Now what do I do? You want me to circle it? Okay.
On the right, put -8.
On the right, put -8.
On the left, put -10.
Left, put -10. Okay.
And then
Shade to the left because it's all the numbers that are less than. Should I color in the circle, Casey? No, because it can't be -9. It has to be less than -9. Remember, if the variable is on the left side, the arrow is pointing in the direction of the shading, right, Caroline? Do you see that? Since the variable's over here, it's pointing in the direction I should shade. All right? Good. Let's look at the next one. Division. You know what? I'm not going to read through this because I told you it's the same exact thing. if I divide by a negative number on both sides, then I need to flip the inequality. Okay? You should be writing this example down. You've got stuff to do. Okay? Now, example number 2 says, solve the inequality, graph your solution. What does it mean to solve, Peyton?
Get the variable by itself.
Get the variable by itself. John D, is it by itself?
No,
What's happening?
they multiply by negative
Okay, so how do I undo that? By?
10.
Okay. Now what do I do?
This is always what you divided negative 2 by 30.
You mean 34 by negative 10, right?
Yes, right.
Okay, good. Good job, John D. Now, Lou, what do I have on the left side?
You have T.
Good. Caroline, what do I get on the right side?
Negative 3.4.
Negative 3.4. Good. And what do I get in the middle, Allison?
Well, you have to flip the sign so you get a less than or equal to.
Exactly. Even when it's an equal to, I flip that as well, right? So T is less than or equal to negative 3.4. Yeah, great.
Then, yeah.
Hang on, no, didn't want to call on you. McVee,
Sure.
now what do I do?
Well, now you put a line in the middle.
Wait, hang on one second. What, Gray?
Never
I thought you had a question. I didn't want you to answer next. I wanted to call on someone else.
Oh.
McVee.
Dash in the middle.
Dash in the middle. Okay.
Negative 3.4.
Negative 3.4. Good.
To the right. Negative 3.3.
Good. Okay.
The other side, negative 3.5.
Excellent. Hang on there, McVee. Nice job. Caroline?
Okay, so, it's pointing that way. Okay, wait, no, first you
Yeah.
circle
Put a circle.
negative 3.4.
Negative 3.4. Okay.
Shade it in
Shade it in. Why am I shading it in?
because it's less than or
So
greater
it-
than or equal
Okay, so it can be equal to negative 3.4.
to. Yes, and then you shade to the left.
Shade to the left, because it says that T has to be less than that number,
And it's
right?
direction the arrow's pointing.
And since the variable's on the left side, the arrow is pointing in the right direction that we shade. Okay? Nice job. Very nice. Now let's look at this next one. Solve the inequality, graph your solution. All right, we can do that. What's it mean to solve, Catherine? No, that means simplify. What's it mean to solve?
The variable by itself.
Get the variable by itself. Lou is the variable by itself.
No.
No, what's with it, Gray?
The 2.
The 2 is with it. What's happening, Izzy, between the 2 and the variable? So what do I do to undo that? Division. What should I divide by? 2. Okay. All right. Now, John D, what do I get on the left side?
You get X.
X. And Casey, what do I get on the right side?
Negative 4.
Negative 4. And what do I get in the middle? Great.
You get a, I don't know how to say that, but you get the sign going eating the 4, the negative 4.
You want it to eat the negative 4?
Yeah.
So you're trying to flip it.
Yes.
Okay. We don't want to flip it. Why do we not want to flip this one?
You're multiplying by a positive.
Exactly. I tricked you.
Yeah, you did.
All right? Because I'm not dividing by a negative. I'm dividing by a positive. So the inequality remains
Eating something.
eating the x. All right? Greater than. Greater than. You're not in 5th grade anymore, so we're going to use the greater than, less than
Sorry,
term.
I just didn't
Okay?
know.
That's okay. This one always means, that way is greater than. This way is less than sign. Okay? Now we need to graph it. All right? Bennett, what do I do?
You put negative 4 in the middle and circle it,
Okay?
and then negative 5 to the left,
Negative 5 to the left.
and negative 3 to the right.
Negative 3 to the right. All right, hang on there. Good. Lily?
Yes. Oh, sorry.
Yes. I am Lily.
Negative 4
To the right, okay? Should I shade in the circle, Lily? No, because it says that x has to be greater than negative 4, not equal to it, okay? All right, one more. Let's look at it. Training. I'm excited about this. Excited about this. While training for a marathon, you try to consume at least 2,400 calories each day. That sounds about right for someone my size. If you were bigger than me, you might need to have a few more calories. If you were taller, weighed a bit more, it takes more energy to move a bigger body. Okay? That's about right though. Now for one meal, you like to eat at least 500 calories. Okay? You choose to eat pasta that has 200 calories per cup. How many cups of pasta should you eat? Now remember, a word problem, the thing that they're asking for is always the variable. What are we trying to find out? What are we asking for here? Luke?
How many cups of pasta
So C.
All right, so C is going to stand for cups of pasta, right?
Caroline.
Okay. Now, what do I do to that C to put it inside of an inequality here? Okay. Caroline?
Okay. It's probably.
Now we know we want to get at least 500 calories, and there are 200 calories per cup.
So, let's see. Okay, so 2,400.
Nope, that has nothing to do with our problem, does it?
Okay.
That's called extraneous information. It's extra, we don't need it.
Okay. So
For
you're
one
trying
meal.
to- So 500 C.
Mm-mm.
No, just 500 then. I'll just do.
Hang on, Caroline. Casey, what do you think?
200 plus
200 plus the number of cups?
yeah, is greater than
200 plus the number of cups.
times.
Well, what do you think it is? What if I had 5 cups? What if I had 200 cups of pasta? Then that would be 400 calories?
Oh, like 200 C.
Okay, 200 times the number of cups.
Oh,
200 times the number of cups? What? 200
Greater than.
greater than or equal to,
You want more?
you want more. It says at least, doesn't it? So you got it. Uh-huh. Is greater than or equal to 500. Nice. I need the calories that I get from the pasta, right? 200 times C, to be at least, which means greater than or equal to 500. Now, Gray, how do I solve that?
you divide, get the variable by itself.
I need to get it by itself, so what do I need to do?
Divide 200 by 200.
By 200.
Then you divide 500 by 200.
Nice. Now, hang on there. What do I get on the left side here, Cedar? Left side. C. Cedar, what can I do on the right side? Well, I can divide. Does anybody see anything quick that I can do?
You can cross out all the zeros.
Okay. What are those zeros? Raise your hand. What are those zeros called? They have a name. They have a name. Bennett? Close. Close. Very super close. Terminal zeros. That means at the end. The terminus. Terminated. Right? All right. So now we're left with 5 over 2. We don't talk about cups, 5 over 2 cups. What do we say, McVie? 2.5. I could write it as a mixed number or as a decimal. So C has to be greater than or equal to 2.5, the number of cups. What if I eat 3 cups? Is that enough? Yeah. What if I eat 2.5 cups? Is it enough?
Yes.
Yes. What if I eat 2.49 cups? Is that enough?
No.
No, that's not enough. One more bite. All right? All right. Excellent job, guys. Perfect. You're ready for your homework. Let me pass it out.